Now we'll see what is meant by power of a lens in this video. Power of a lens is measure of the convergence or divergence of the lens. So we can say if the lens converges more, we can say power is more. If the lens diverges, the light falling on it is more, we say power is more. So what is qualitatively the power of a lens? It's a measure of convergence or divergence of a lens. So how do we define the power of a lens in a quantitative way? It is defined as the tangent of the angle. Tangent of the angle. That's what we normally call as tan of the angle or tan theta. Tangent of the angle by which a lens, it can be a convex lens or concave lens, by which a lens converges or of course diverges. Diverges. A light beam falling on it, a light beam falling on it at unit distance, from the optic center, So tangent of the angle by which a lens converges or diverges. A light beam falling on it at unit distance from the optic center. Let's say this is convex lens, this is the optic center. My diagram is a rough diagram. Optic center. Let's say a light beam is incident on it. Say this is H. When the light falls on it, I am taking a paraxial ray, a ray close to the axis and parallel to it. After refraction, it will pass through the principal focus. So this is F, small f. Capital F is the principal focus, small f is the focal length. This is the angle. Or you can even say this is the angle. Actually the ray has to go this way, but it converges by this angle. So tan of this angle, when H is 1, that is called power, right? So if this is theta, this has to be theta, alternate angles. So tan theta H by F. Okay, if theta is small, you can write tan theta as theta. H is 1 because when you define optical power, you will have to consider this H as 1. You see, unit distance. So 1 by F. Therefore, the power is defined as 1 by F. Tan of the angle by which a lens converges or diverges a light beam falling at unit distance from the optic center. Falling at unit distance, make H1. So power is 1 by F. And the power SI unit is diopter. Symbol is capital D. SI unit diopter. So 1 diopter is 1 meter inverse. 1 diopter is 1 meter inverse. See, for example, if you are asked to calculate the power of a lens whose focal length is 1 meter. Power of a lens, focal length is 1 meter. Or we say power of a lens whose focal length is 25 centimeter, let's say. Let's say power of a lens whose focal length is 25 centimeter. We want to calculate the power in diopters. So what you should do, Straight away you don't write power is 1 by F, so 1 by 25. So many diopters you should not give, this will be wrong. To get the power in diopters, the focal length should be in meters. So what first step you should do, convert that 25 centimeter into meter, 0.25 meter or 1 by 4 meter. So power is 1 by F, so 1 by 1 by 4, 4 diopter. Positive power means convex lens, negative power means concave lens. Is it okay? Yeah.